This is the last video for Chapter 6 exam review, so video number 3. We'll pick up from where we left off. And where we left off last time was looking at number 3, where we decided how to start that substitution. So we're looking at 3a. And so we had left off with knowing that we should take 6x minus 11 and put it in for that y value. So check to see if you were successful in your substitution. It should look like that. Then please double check that you were successful in your distribution, especially that positive 33. Continue solving for x. And once you have an x, remember then you can go back to the boxed up part, put it in for x, and solve for y. On part B, pause the video wherever you need to. On part B, we're doing something similar, but first we had to move it around so that we could find out what an x was worth. Then we came to this equation, and here's my substitution for the x value. Then check your distribution and your work, and when you get to 12 equals 12, you have to decide how many solutions this system has. When the variables eliminate and you get down to something that's true, it means there's infinitely many solutions. But what the solutions are, because when they graph they'd be the same line, is we're saying that the top equation and the bottom equation are really the same equation, and the same things that solve the top one solve the bottom one. So your answer here, even though there are many, what are they? Any solution to, and then you name one of the equations. You're saying that basically if it solves this one, then it solves the other one. Then on number 4, you were doing elimination. Pause this video where you need to. We got you as far as 3x equals 30 last time, so you should have been able to come up with x is 10. Then I grabbed one of the equations, and where the x was, I put in 10, and you need to solve for the y value still. Again, pause the video if you want to stop and finish that one before you move on. In part B, when we eliminated, we got to this step right here where we left you ready to eliminate, so you should have been able to get to the negative 4x is negative 16 step. Solve for your x, and then go put it back into one of the equations and finish that one by solving for y. So make sure these are finished. This video does not finish the problems for you. In number 7, then, you don't solve the systems. You're going to be specific about what method you would choose, so determine the best method, but then you need to explain why, but don't solve the system. So for instance, I might look at letter C, and I notice that they're both in y equals form, and they're both in that slope-intercept form. So I might say graphing, but what you say afterwards is really the answer to the question, not just naming a method. I might say graphing since both are in y equals mx plus b. So I don't just get to say because it'd be easier. Then you need to name a method here and give a short reason why. And then decide what method you might use to solve number 3, part B, and give a short reason why. Okay, so pause the video, decide which way of elimination, substitution, and graphing you might pick to solve a certain system, and give your reasons why. Finally, when you get to number 8, it's no longer equations, they're inequalities. And when they're inequalities, we want to take these one at a time. So when these were inequalities, make sure you have some steps for these somewhere on your note sheet, because I think for some of you that will help a lot. You have them on your note card from chapter 6, or you should. For each of these inequalities, first we graphed their boundary, and we decided some things about their boundary. We decided if it was already in slope-intercept form, we decided what the slope of their boundary would be, what the y-intercept of their boundary would be, and whether it should be solid or dotted. And so I will go through one of them with you, and we'll get the big idea, and then you can finish that up. So for this first one, the boundary, I can already tell, looking at my slope and my y-intercept, that I can read from it that the slope for its boundary line should be half, which means I'd go up 1, right, slope, and forwards 2, and the b value's 2. And since I can see that it's less than or equal to, that means the equals part counts, therefore I would graph this one solid. So I need a solid boundary line with a y-intercept of 2, and a slope of 1/2. And here's where you really want to get a couple extra points in there. You could even go backwards. so that your solid boundary line is in really good shape. Okay, so I'm going to put my solid boundary line in. Let me get my boundary line a little bit longer here. Adding that on. Okay. But I'm not done because that doesn't give me where all the solutions to that inequality are. So then I need to test a point. We need to test a point not on the line. I'm going to test 0, 0. It goes back into your original inequality to see if it satisfies it. Is 0 less than or equal to 1/2 times 0 plus 2? I want to simplify this side. 1/2 times 0 is 0. Add 2 is 2. Is 0 smaller than 2? And that's true. So when I tested 0, 0, for this one, it makes it happy. So 0, 0 being right here is my test point means that solutions to this particular inequality fall on the side 0, 0 is on. So instead of shading right away, because we're going to have shading from our other line, I went ahead and put in where I would shade. Now to finish this one up, you need to do the same for this second one. You need to take the other inequality. You need to find its slope, its y-intercept, whether it's solid or dotted, and do a test point. Once you have that done, you could come back to the video and then think about whether or not you're going to shade in a certain place. So why don't you pause the video and come back when you're ready. Try this one out. If you're back, or if you're back because you're stuck or because you actually got it done, let's do a quick. The slope on this one should have been -2. The y-intercept should have been -3. So looking at this one, you should have a boundary line. It's got a -2 slope. I'm going to go backwards here and put these in. And it should be dotted because it's not in less than or equals to form. It's just less than. Now, I can't really do that with mine. So what I'm going to do is go over the top of mine and say, you're dotted. Just do it with a different color. So this one should be dotted. Remember, if you forget, you're going to go over on the side, just write me the word dotted so that I know what you meant. So if you forgot, go fix that. Okay, same on the exam, because part of the credit will be knowing that that one should have been dotted. I can test 0, 0 way over here. So you could have picked any other point. I'm going back to my inequality to test it. And this would say that 0 is less than -3, which is false. 0 is not smaller than -3. So if that makes that 0, 0, I don't want to shade up to the side of my pink line that 0, 0 is on. I want to shade away from it, saying 0, 0 is not a solution for that, so it would not be part of the solutions for both of them. Once I've got my arrows in, and remember I want arrows up and down both lines so that I can see in these 4 regions. So I've got this yellow region up here, don't shade yet. I've got this green region over here, the blue region down here, and we'll go orange. Got this orange region over here. There's 4 regions that those 2 lines make. Now I want to know which region has solutions to both inequalities, so I have to look at which region both of them are pointing into. And on ours, it's that blue region down here that these arrows are pointing into and these arrows. So then the solutions to both inequalities are in here, and that should be where our solution set falls.